Hey everybody, Mr. Jones back with you here. We are still on quadratic functions, the never-ending unit, but now we're on to one of our last couple lessons called quadratic systems. Now in Algebra 1, you would have went over linear systems of equations, but basically all a quadratic system is when you have two equations within the same problem, okay? And so what you're looking for are points, or there could be multiple points, there could be a single point, or there could be no points. That are common solutions between both of the equations, okay? So you notice both of these have x and y values, okay? So our answers to these are going to be x comma y ordered pairs. So for this one, find the solutions to the quadratic system, okay? And it should say solutions with a s in parentheses because there's not always multiple solutions. Sometimes there's just one. Sometimes there's zero, like I said. So we look at this, okay, we have two different equations here. And if I'm solving this, okay, there's a property called the substitution property that says, right, if two groups, right, and so if I kind of have one group here and one group here, okay, and you notice it says y is equal to this group, and it also says y is equal to this group, okay. So if both of these different groups equal the same thing, that means these two groups have to equal each other, okay? And so what I can do is write the two groups. I'll write the bottom group x plus 3, and then I'll write my bigger group. It doesn't really matter what order you do it in. But you set them equal to each other because both of the groups are equal to the same thing. So I'm allowed to set them equal to each other. That's what I have. And so what I'm going to do here is, just like we've done with quadratics all through this unit, I'm going to get all the terms on the same side because what I want this to say is I want it to say equals 0, okay? Right now I have all these terms on two different sides. So what I'm going to do, and I'll just tell you, my life is made a lot easier when this x squared has a positive 1 coefficient. So I'm actually going to plus the x squared. And I'm just going to do it all at once. I'm going to plus this single x term, and then I'm going to minus this 6. So I'm going to cancel everything over here, okay, and add them all over to the other side, get everything all together, okay? And so now this right side says equals 0. And on this left side, I'm going to have some things to combine, but that's okay, all right? So I look at this, okay, I have this positive x squared, and there was not an x squared over here before, so I can just write, there's 1x squared over here, okay? So, and then there was 1x, and now I'm adding one more x. So 1x plus 1x would give me positive 2x, okay? And then I had positive 3 over here, and now I'm doing minus 6. So 3 minus 6 gives me a negative 3. So now this is my group, and I have this trinomial, right? Let me rewrite it up here. And so what I want to do at this point is factor this, if I can, okay? I want to factor it, because that will give me an easier way to get the x answers to this, right? Because my end goal is to find my ordered pairs. Because, right, if these have y and x values, I need to find the answers to both of those. So, but for now, I'm just focusing on x, okay? And I'm going to try to factor this trinomial using tic-tac-toe. So let me draw a little board here, okay? So I've got my x squared, I've got my negative 3 is in the middle, and then my plus 2x is on the right as my check column, okay? So I think, okay, what multiplies to give me x squared? That would be x times x, okay? And then what multiplies to give me negative 3? Well, we have a couple options, but again, what I'm trying to get is a positive 2x over here, okay? So, right, the only things that really multiply to give me 3 would be 3 and 1. But again, I want these to add to give me positive 2x when I multiply them, right? So I would have 1 times x, 1x, x times 3, 3x. But which one do I want to be negative, right? If I want to be 2x, I want this one to be negative, right? I want it to be x times negative 1, negative 1x. So when I add them, it gives me 2x. So I have that, okay? And my two groups are going to be x minus 1 and x plus 3. Now, I know I did that pretty fast, and if you need a refresher on the tic-tac-toe factoring, you could look at some of my other videos, but that is the factored version of this trinomial, okay? And then again, we talked about before how we can solve quadratic equations using this factoring, okay? So now that I have these two groups, I can say, okay, this x minus 1 could equal 0, and then this x plus 3 could equal 0, and I could solve them for x, right? So if I do plus 1 to both sides, I would get x equals 1. So that is one x solution, and then for this one, I could minus 3 to both sides, and we'll get x equals negative 3, okay? So what I just found are my two x solutions, okay? I'm not done yet. I know it's been a lot of work so far, but I'm not quite done, okay? So I found my two x solutions. So right now, for my answer, I kind of have partial ordered pairs, right? If I'm trying to find an x and a y value, I know that one of my ordered pairs is going to have 1 as an x value, and then the other one is going to have negative 3 as the x value. But I still need to go back, and I need to substitute those in, and I need to find my y values, okay? And how I do that is I go back and I substitute these values in, okay? And that's actually a lot easier to do than what we've been doing, okay? What I can do is I can even just take this easier equation right here, the second one, and I can substitute in these two x values into there, okay? So this is my last step. I take these x values, right? So the first one was 1. So instead of y equals x plus 3, I take y equals 1 plus 3. Because I know my x answer now, right? I know my two different x answers, so I can go back to the original equations and substitute the x values, the x answers that I know in here to find the corresponding y answer that goes with that. And that's easy, right? 1 plus 3 is 4. So y equals 4 when x equals 1. So 1 comma 4 would be one of my answers, okay? And then the other answer, same thing. If I plug in negative 3, y equals negative 3 plus 3. So y should equal negative 3 plus 3 is 0, okay? So negative 3 comma 0 would be my other solution, okay? So those are my two answers to this whole quadratic system, okay? 1 comma 4 is the first point, and negative 3 comma 0 is the second point, okay? Now, we did this mathematically by hand, but on a graph, what you would see is you'd see a quadratic curve. If you graph this first equation, you'd see a quadratic curve, open and downwards like a frowning face, and then you'd see a straight line kind of going through it, okay? And these 2 points would be the 2 points where the line crosses through your frowny face curve. So that's what you would observe if you looked at the graph of this, okay? And like I said, later on, I'll show you different equations that you can solve in Desmos, okay? But for now, let's just nail down this process. We're going to do one more together, and then I'll show you the graphing, okay? So let me erase this. Okay, so I've got example 2 up here, similar, right? Same directions, find solutions, or just maybe one solution. But okay, so we look at these. Again, the setup begins with kind of taking these two equations, the x part of the equation, not the y side, and setting them equal to each other. And so from here, right, I want the one side to say equals 0. So in this one, the x squared value is fine, okay? Just in the other one, it was more beneficial it made my factoring a little bit easier. Usually we want this a value to be positive. That would be priority 1, okay? And if it is, like in this one, it's positive 2, yeah, I can kind of leave it where it is. So it doesn't really matter. You can get the right answer either way, but that's just preference, having the a value be positive. So I'm canceling out everything on this right side so that it says equals 0. And then over here on the left, I have 2x squared. I combine my x terms, so I have negative 5x minus 3x gives me negative 8x. And then I have 6 plus 2 gives me positive 8. So that is what I have here, okay? Something else I'm going to do right here, okay? You observe that 2x squared minus 8x plus 8. We've dealt with this a little bit with quadratic equations, right? If you notice, I have a GCF, right? You notice all my coefficients are positive. So I'm allowed to do this. I'm allowed to divide by 2. As long as I divide everything by 2, that's legal, okay? That's legal for me because that's basically similar to me of factoring out a GCF, but with an equation with the other side being 0, basically I can get rid of that GCF altogether, okay? So if I divide everything by 2, I'm left with x squared minus 4x plus 4 equals 0. And again, 0 divided by 2 is 0. So I just made my life, when I go to factor this now, I just made my life a little bit easier because I'm going to be dealing with smaller numbers, and I was able to catch my GCF early on. Okay, if you didn't catch your GCF early on, it's okay. You would have had to find it after you factored, but no big deal. Okay, and now I'm going to factor this. Okay, and again, I'll make my tic-tac-toe board, and then I go to check this, or I'm going to check it after. Okay, I go to, right, what multiplies to get x squared? Well, that's x times x. Okay, and then what multiplies to get 4? Well, I either have 2 times 2 or 4 times 1, right? But to observe something, this check value is negative, but this C sign is positive, right? So we said that the only way that's possible is if both my groups had negatives in there, right? If this is positive, but the B sign is negative, these both have to be negative in here. So it's either -4 and -1 or -2 and -2, okay? And with a little bit of forward thinking, I'm able to think, okay, -2 and -2 is going to give me that check value that I want. If I did -4 and -1, those would add to -5, and I don't want that. So -2x is what I'd get when I'd multiply across, okay? And then when I add to check, -2x plus -2x gives me that -4x that I want. So I actually have two identical groups here. X minus 2 and x minus 2 is what I'd get when I'd factor that trinomial, okay? So now just rewriting it, because I'm going to solve x minus 2 equals 0, okay? Look at this. So in this instance, right, we have two matching binomial groups. And in this case, there's only going to be one x answer, because there's no, I mean, I could solve them both separately, x minus 2 equals 0. But there's only going to be one answer, one x solution that would make either of these groups 0, right? So basically, my only x answer here would be +2, right? If I added 2 to both sides, x would equal +2. Okay. So again, with quadratics, there's a little bit more, right? With comparing it to linear systems, there was always one answer, or sometimes, like if the lines were parallel, there was no answer. Okay. But in this case, with quadratics, there can either be two answers, one answer, or zero answer. There's more possibilities. But in this case, there's just one, right? So my x value is 2, and I still need to find that y value that goes with it, okay? And that's easy. I go back and I plug that in to my, and you just do yourself a favor and plug it into the simpler, the smaller equation here. So instead of y equals 3x minus 2, I know my x answer now, so I substitute that in. 3 times 2 minus 2, okay? So y equals 3 times 2 is 6, and 6 minus 2 is 4. So when x equals 2, y equals 4, and that is my answer. So there's just, I know I did that a little quicker than normal, but I do want to squeeze in how to do this on Desmos as well here, okay? So that's how you solve it using substitution and factoring, okay? And now I'll get into how to solve a quadratic system using graphing, okay? Alrighty, everybody, in Desmos here, and we are going to solve these quadratic systems involving at least one quadratic equation, sometimes two. Okay, so if we just type in straight up, we don't need to include that fancy bracket, but if I just type in -x squared plus 3x plus 2, right? That first parabola shows up, okay, and that's good. Now if I type in the second equation in a different blank, 3x minus 2, again, what we want to look for, again, with solving with substitution, we're getting those two ordered pair answers, an answer for x and an answer for y. But when I can solve by graphing, like these directions say, I can just look for the intersection points. Okay, and Desmos here highlights a whole bunch of points for you. And it does highlight the 2 points where the purple line here crosses through my green curve. Okay, so it just highlights those for me, -2, -8, and 2, 4, and it's just as easy as that. Those are my two answers. And you could check your answers like the directions say. I'm not going to show that, but you can check your answers by just substituting those numbers in. Specifically, you could substitute in the x values, and you can see if the answer results in that y value. Okay? Now if I look at 24, y equals 2x squared minus 4, and then y equals x squared minus 4x plus 1. I see there. Okay, now let's look at this. Okay, 1 comma negative 2 is my one answer. And you just might be looking at this like, is there another answer? I just see the 1 intersection. Well, let's zoom out and just make sure. And whoa, way up here. Again, Desmos highlights it so it's nice and easy so you don't have to zoom in. But let's zoom in just for the heck of it. So that point, 5 comma 46, if you didn't zoom out, you might have missed it. So negative 5 comma 46 is indeed another shared solution from these two equations, so that's where they intersect. Okay, now I added a question in here at the bottom, 25. Yes, 25. So if I type that in, okay, let's go back to my standard center of the graph, y equals x squared minus 5. You see my parabola there. Then I type in y equals negative x squared minus 8. Okay, what's the deal here? We look at these curves, and one is going to be going right. The lowest it ever goes is negative 5, and we know from domain and range this will go up forever and ever and ever. And then this red curve, the highest it ever goes is negative 8, and it's going down forever and ever and ever. Okay? So what would I say here? These don't intersect anywhere. And yes, so you would say, in that case, that would be an instance where there would be no real solutions to this problem, okay? Because they don't intersect anywhere, okay? There's also certain cases where your line, like a parabola and a straight line, can intersect only once. I didn't show any of those, but that is also a possibility. So a lot of them have 2 answers, but it is possible to get 1 or 0 answers as well. Alrighty, so that's quadratic systems for you. Thanks for following. See you later.